Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Our mysterious neighbor Mars is full of mysteries. Have you ever wanted to know what they are? Discoveries made by NASA on the Red Planet have consistently transformed our knowledge of this faraway place, from intriguing proof of water flows to enigmatic chemical compounds. Fresh research confirms the existence of subsurface frozen water on Mars. Let's go out on an adventure to investigate these intriguing results. First and foremost, proof of long-gone water flows. After centuries of being believed to be a dry and dead world, NASA's painstaking examination of Mars has revealed the red planet's wetter, more vibrant past. As if playing the role of cosmic detectives, spacecraft in orbit and on the ground have collected convincing evidence of long-gone water flows. Dry river valleys, deltas, and lake beds are apparent in the Martian terrain as relics of past flows. These are especially noticeable in Gale Crater, where the Curiosity rover found evidence of past habitats that were altered by water. These dried-up rivers and streams from long ago show that Mars wasn't always this frigid and desolate place. Instead, it could have previously contained habitats that were comparable to early Earth and could have supported life. This discovery not only changes the way we think about Mars' past, but it also adds fuel to the fire of the intriguing idea that the red planet may have once been home to life or even harbors life in some form somewhere on the surface. Second, organic molecules. The Curiosity rover operated by NASA found organic compounds on the surface of Mars, which is a sensation in the scientific world. The organic compounds discovered in Martian soil and rocks are the fundamental basic components of life. The existence of these chemicals does not prove the existence of life on the planet, but it does make us wonder if it is habitable. Such molecules are fundamental to life on Earth, but where they came from in Mars's distant past is a mystery. Are these molecules the product of processes that do not include biology, or are they perhaps artifacts from an earlier era? Mars may have formerly had habitable conditions, as this finding provides insight into the planet's past environment. This intriguing clue is driving the search for the origins and possible manifestations of life on Mars. As we continue to explore the Martian soil, it feels as though every grain is hiding some mystery about an unknown universe. Third, methane fluctuations. Mars methane is a mystery that scientists are captivated by. Meteoric bursts of methane, a gas mostly produced by biological processes on Earth, have been identified by NASA's Curiosity rover on its journey across Mars. A great deal of interest and discussion among scientists has been roused by these changes. There may be a comparable biological source on Mars, as most methane on Earth is produced by living beings. This is an intriguing topic to consider. There are non-biological processes that can produce methane as well, including water-rock chemistry and the decomposition of meteoritic debris. These methane increases on Mars are sporadic, which makes the puzzle more complicated. Their apparent ebb and flow at Mars's seasons points to a dynamic mechanism. Identifying a single mechanism is not enough to determine the source of Martian methane. Doing so may also provide light on current geological processes or, even more exciting, indicate the presence of underground microbial life. Therefore, the hunt for Martian methane is a quest to comprehend the present and past life of a planet, not merely a gas search. Fourth, beds of long-dead lakes. The Curiosity rover has opened a glimpse into Mars's aqueous history through the massive gash on the surface known as Gale Crater. The geological and chemical information found in this long-dead lake bottom dates back more than 3 billion years. Similar to the stratified sediment layers found in Earth's rivers and lakes, the crater's sediments indicate a stable and long-lasting aquatic ecosystem. Curiosity's finding of organic carbon molecules and a variety of minerals in these layers adds to the story of a Martian past when life was possible. Not only are these artifacts significant, but they provide light on a Martian period when liquid water was plentiful and perhaps life flourished. Dry and now exposed, this ancient Martian lake bed provides a once-in-a-lifetime chance to learn about the Martian environment in its early stages, which could lead to new insights on the commonality of life. Gale Crater's findings are more than simply scientific facts. They add chapters to the narrative of a planet that may have once been similar to Earth's early habitable conditions. Fifth, ice was discovered. Finding large ice deposits on Mars is a major step forward in our mission to explore other planets and maybe settle them. The polar ice caps and subsurface deposits on Mars contain enormous amounts of water ice hidden beneath the planet's dusty and desolate surface. The results obtained by the orbiters and landers have significant consequences for when humans return to Mars. The water ice on Mars could be a lifeline for future generations, not just a resource. It has the potential to supply oxygen, water for human consumption, and possibly fuel for spacecraft that return to Earth. Furthermore, ice complicates our knowledge of Mars's temperature and geological past. This data points to the possibility that Mars, like Earth, has experienced major climate changes. The habitability of Mars in the past and its future as a possible habitation site for humans can be better understood by exploring these ice deposits. Mars ice is more than simply water. It's a record of the planet's past and a pathway to its future discovery. Sixth, variations in atmospheric gases with the seasons. Ever since the discovery of its seasonal fluctuations, the Martian atmosphere, a delicate layer of gases that covers the red planet, has captivated the scientific community. To learn about these variations in the atmosphere, NASA's MAVEN Mars Atmosphere and Volatile Evolution project is crucial. Curiously, Martian seasons affect the concentration of gases such as nitrogen, carbon dioxide, and argon. Sublimation and polar deposition of carbon dioxide cause these changes, which are far more severe than Earth's. There is a dynamic process at work on Mars since a large amount of atmospheric gas freezes during winter and is then released again throughout spring and summer. Important information about the present and past climate of Mars can be gleaned from this cyclical process, which is similar to Earth's seasonal fluctuations but far more massive. Scientists can learn more about Mars's history and its ability to sustain life by analyzing these patterns, which reveal the intricate relationship between the surface and atmosphere. Seventh, artifacts from a long dead sea. Even though Mars is currently a barren wasteland, there may have been an ocean there once that covered the whole northern hemisphere. Information gathered by orbiters, landers, and rovers has come together to back up this shocking theory. Martian terrain features such as ancient shorelines, deltas, and valley networks are indicative of this. These features are similar to those created by Earth's oceans. If it had really existed, this Martian ocean would have held more water than the North American Great Lakes put together and covered an area greater than Earth's Arctic Sea. Its presence provides strong evidence that the Martian surface was once warmer and more humid than it is now. Concerns over Mars's habitability and climate history are prompted by the possibility of the presence of such a large volume of water, inspiring hope for the hunt for Martian life in the distant past and providing insight into the dynamic evolution of planets. The oceanic relics reveal the tale of a world experiencing tremendous climate change. Eighth, active surface processes. Recent observations show that Mars has dynamic surface processes, which contradicts the static and changing image of the planet. The key tool in the discovery of these events has been the Mars Reconnaissance Orbiter (MRO). Features such as moving sand dunes, which may indicate active wind processes, and recurrent slope lineae, which may indicate seasonal water flows, are seen in MRO images. The long-held belief that Mars is geologically dead is challenged by these facts. Rather, they depict a world where wind, temperature changes, and perhaps even fleeting water flows continue to affect the landscape. In order to learn about the current weather and atmospheric conditions on Mars, it is essential to comprehend these processes. These fluctuations in the surface's activity are more than just cosmetic. They hold the secret to Mars's climate and environmental history, which will shed light on the red planet's habitability in the past and direct our exploration efforts in the future. Ninth, extensive geological past. Mars is a planet that shows the marks of time and has a geological history that can rival the best yarns. The landscapes of Mars reveal a story of continuous transformation, from massive volcanoes to expansive canyons and old river systems. The analysis of these features by missions such as the Mars Reconnaissance Orbiter and other rovers has shown that there was substantial geological activity in the past. Mars has a rich history of volcanic activity and tectonic upheaval, as evidenced by its Grand Canyon and the solar system's greatest volcano, Olympus Mons. Also, sedimentary rocks like Gale craters indicate that water was there for a long time. These varied landscapes provide evidence that our planet has been through a wide range of climates and ecosystems throughout its billions of years of existence. Mars' complicated geological past casts doubt on our assumptions about the red planet and suggests that it has evolved much like Earth in its early stages, rather than being a static world. 10th, perchlorates in the soil. Finding perchlorates in Martian soil during NASA's Phoenix lander and subsequent flights has opened a can of worms regarding the possibility of life and future human exploration. The Martian soil contains perchlorates, a class of chemical compounds that may have beneficial and harmful uses. These molecules may provide nutrients for hypothetical microbes, raising the prospect that life may be able to survive on Mars despite the planet's hostile atmosphere. Furthermore, perchlorates present a formidable obstacle to human settlement. These compounds make it harder to cultivate crops or extract water from Martian soil, and they are also potentially harmful to humans. Thus, perchlorates are a double-edged sword. They bring both exciting new opportunities for astrobiology and formidable obstacles to future human exploration of Mars. 11th, proof of volcanic activity. The history of Mars, etched in ash and lava, is visible all over the planet's surface. Olympus Mons, a shield volcano that is larger than all of Earth's mountains combined, stands as the most monumental symbol of this volcanic activity. The presence of other volcanoes, such as those in the Tharsis and Elysium regions, suggests that volcanic eruptions were a common occurrence during Mars' geological history. These dormant volcanoes from long ago reveal important information about Mars's thermal history. Scientists get insight into the mechanics of the planet's crust and mantle through studying their patterns of formation and erosion. In addition, volcanic eruptions may have been major contributors to the early Martian environment that was warmer and wetter, making it more hospitable to life. Therefore, the volcanic features of Mars are more than just interesting geological artifacts. They provide insights on the planet's volatile core, its possible habitability in the past, and the conditions of its environment today. 12th, old impact craters. The past of Mars is woven into the surface as a mosaic of impact craters, each one bearing witness to the cataclysmic collisions that have molded the planet. From newly formed, pristine bowls to weathered, ancient relics, these craters tell the story of the solar system's evolution in chronological order. Both large craters like Hallis Planitia and numerous smaller ones over Mars' surface attest to the planet's repeated bombardment by asteroids, meteors, and comets in the past. The impact of this bombardment on Mars' atmosphere, surface, and possibly habitability was significant throughout the planet's geological history. Martian surface ages and former habitats can be better understood by analyzing the location and shape of these craters. Also, the crater layers show what's underneath the surface, so we can see what Mars is made of and how it's structured. Therefore, these long-gone impact craters are more than just surface scars. They provide crucial clues to Mars' turbulent history. 13th, meteorites from Mars land on Earth. Interplanetary travelers, meteorites from Mars provide a unique window into the history of the red planet that humans have been fortunate enough to unearth. Scientists have an essential resource in these unusual rocks that were expelled from Mars' surface by impacts in the past. These rocks journeyed through space before they landed on Earth. By analyzing these meteorites, scientists have learned a great deal about the composition of Mars' atmosphere, its volcanic past, and whether or not the red planet ever had water. They hold information about the Martian interior that rovers and orbiters cannot reach. The formations on some of these meteorites, such as ALH 84001, resemble tiny fossils, and this has sparked discussions among scientists over the likelihood of Martian life in the past. Complementing data from space missions, studying meteorites from Mars on Earth helps fill in gaps in our knowledge of Mars' geological history and provides a concrete, hands-on way to relate to our neighboring planet. 14. Water-formed minerals. Finding Martian minerals that can only be formed by water is a major step towards understanding the Martian past as a habitable world. Curiosity and Opportunity, two rover expeditions, have found water-required minerals like as gypsum, clay, and hematite. Based on these results, it seems that Mars' surface might have supported liquid water for long periods of time in the past. According to the mineralogical composition, which provides information on the formation conditions, ancient Mars may have had water that was neutral to slightly alkaline, which might have been a good environment for life. This finding does double duty. It strengthens the case for a wetter Mars and helps direct future planetary exploration efforts toward the most promising locations in the hunt for Martian life. These water-formed minerals change our impression of Mars from a desolate wasteland to a planet that might have previously hosted the building block of life. 15. Dust storms. Dust storms, among the solar system's most mysterious weather phenomena, originate on Mars, the planet known for its crimson dunes and stony plains. Martian weather is defined by powerful storms that can range in size from little dust devils to storms that encircle the planet. These storms have far-reaching consequences for Martian ecosystems. Fine particles ejected from the Martian surface form dust storms, which can cover large swaths of land and, on rare occasions, completely engulf the planet. The most powerful of these, called global dust storms, hit Mars' atmosphere hard and come and go without warning. They can linger for weeks or months. Solar power available to rovers can be drastically reduced during these storms, which can influence their operations. These storms pose a double threat to future human missions: decreased visibility and equipment damage. Atmospheric temperatures rise because the dust in these storms absorbs sunlight and gets hotter. The dust can be dispersed even further if the heating causes turbulence and strong winds. In order to plan future expeditions to Mars and anticipate its weather, knowledge of these dust storms is crucial. As a major player in the climate system, storms can influence chemical processes and atmospheric loss by lifting substances like water vapor into the sky. 16th, atmospheric escape. The red planet's atmosphere is slowly being eroded by the constant assault of solar winds. It is a thin layer of gases that covers the planet. The atmospheric escape process is an important piece of the puzzle when trying to piece together Mars' environmental and climatic history, as well as the planet's evolution. In contrast to Earth, Mars does not have a worldwide magnetic field that can shield the atmosphere from the damaging effects of solar winds. The Martian atmosphere would be totally vulnerable to the solar winds, the thin stream of charged particles, entire force if this shield weren't there. Over the course of billions of years, Mars' atmosphere has been gradually stripped away by the sun, turning the once warm and moist planet into the frigid and dry one we know today. The Mars Atmosphere and Volatile Evolution MAVEN mission, which is run by NASA, has played a crucial role in understanding this process. Solar winds accelerate and carry away gas particles as they penetrate the upper atmosphere, as indicated by MAVEN's findings. Lighter gases, like hydrogen and helium, are more readily taken away than heavier gases, so this loss is quite noticeable when they escape. 17th, levels of solar radiation. Humans face a formidable obstacle in the form of solar radiation on Mars. Radiation levels on Mars have been being monitored by the Curiosity rover, which is equipped with the RAD. Due to Mars's thin atmosphere and absence of a worldwide magnetic field, these measurements are of the utmost importance in protecting the red planet from potentially dangerous solar radiation and cosmic rays. Based on the data we have, the radiation levels are too high for human health over long periods of time. Because of this, sophisticated radiation protection for shelters and spacesuits is essential for manned mission preparation. If humans are to continue exploring and maybe colonizing Mars, it is critical that we understand and reduce these radiation hazards so that astronauts can do so without harm. 18th, selfies with rovers. In the vast and lonely Martian landscapes, rover selfies have become an unexpectedly charming part of space exploration, capturing the attention of the public and giving a human face to the robotic explorers from another planet. Beyond being a technical achievement, these collages of photographs that form selfies connect the frigid, otherworldly landscape of Mars to the welcoming, inquisitive gazes of humans on Earth. Taking selfies like PROS, Curiosity, Perseverance, and their predecessors have given us a window into their solo adventures across Mars. Their robotic arms are equipped with cameras, and they take their own pictures against the background of an interesting and varied Martian terrain, which includes rust-colored plains, the borders of old lake beds, and the slopes of tall volcanoes. Publicly, these photographs make the rovers seem less like remote-controlled machines and more like approachable, almost personable people in a fantastic space adventure. Privately, they aid NASA experts in scientifically monitoring the rover's wear and tear. The capacity of rover selfies to bring a human touch to space exploration is what makes them so appealing. These pictures make a complicated technical endeavor into a tale that millions of people all across the world can relate to. With their robotic arms and camera eyes, the rovers become heroic explorers that we can identify with. Taking a selfie is like stepping into a moment of connection. It's a constant reminder that these robots are nothing more than extensions of human curiosity and creativity, toiling away from us in complete isolation. 19th, nighttime temperature variations. Mars, with its stunning and bleak landscape, is also home to some of the solar system's most dramatic temperature fluctuations, a reflection of the planet's complex and ever-changing ecology. The Martian environment and its implications for robotic and human exploration have been studied in relation to these temperature changes, especially the dramatic nighttime dip. Martian days can be hot enough to momentarily melt water ice due to the surface's ability to absorb heat from the sun and its thin atmosphere. Nevertheless, as night falls, temperatures plummet dramatically due to the absence of a dense atmosphere, frequently falling well below freezing. This contrasting event can happen on Mars in the span of a single sol. Nighttime lows of 100 degrees Celsius or below are not unheard of in several parts of the world. Instruments such as the Mars Environmental Dynamics Analyzer, MEDA, on the Perseverance rover and the Temperature and Winds for InSight, TWINS, on the InSight lander capture this phenomenon, which is essential for understanding the climatic dynamics of Mars. The mechanical operation of spacecraft and rovers is affected by the extreme cold, as is the possibility of future human colonization. Everything from equipment to habitat materials have to be tough enough to survive these extreme circumstances. The capacity of Martian soil to hold heat and the possibility of liquid water stability on or near the surface can be better understood with an awareness of these temperature changes. 20 of Mars quakes. Major step forward in our knowledge of Mars innards and geological past was the identification of seismic activity, sometimes known as Mars quakes. These tremors provide a rare window into the inner workings of a tectonically dormant planet like Mars, which lacks tectonic plates like Earth. An extremely sensitive seismometer called SEIS, Seismic Experiment for Interior Structure, was important in identifying these earthquakes on Mars. The InSight lander, which is operated by NASA, is equipped with this instrument. Earthquakes ranging from small, hardly perceptible vibrations to larger, more powerful quakes measuring up to 4 on the Richter scale have been detected. The planet's cooling and contraction, which causes stress fractures in its crust, is thought to be the source of these earthquakes. Some of them might have been caused by volcanic eruptions or impacts with meteorites. Mars quake data analysis opens a previously unimaginable window into the Martian subsurface. When these earthquakes happen, they send out seismic waves that bounce about the Earth, revealing details about its inner structure like the composition and thickness of its crust, mantle, and core. Seismic research is like taking a sonogram of Mars. It lays bare the red planet's structure and gives information about its evolution and temperature. Research into Martian earthquakes is an emerging field in the study of the solar system. As a bonus, it gives us more information to use in comparing Earth to other rocky planets and deepens our knowledge of Mars. Our understanding of solar system tectonics and planetary formation can be enhanced by studying Martian earthquakes and comparing them to Earth's seismic activity. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.